So if we connect A and B, so this is our second line, and if we want to draw a tangent line at C point, so these two lines will be parallel to each other, and their slope will be same. The slope of AB is FB minus FA by B minus A. So why this came? Because we know that slope means y2 minus y1, right? y2 minus y1 by x2 minus x1. So here A and B is our x, here B is x2 and A is x1, right? And y2 minus y1. So if you just take some point here, so this point will be y1, and if you just take a point here, so this point will be y2, okay? Or you can also say FB or FA, like as we mentioned here. This is FA, that means here FA, and we have we have FB, that means here. Okay, guys. Tupu, can you understand?
Yes, yes.
Okay.
Any example for this role?
Maybe we have some example.
Any example here?
Yes, I think so. Let me find some example.
Okay, okay. It would be better for understood.
Yeah. Constant function.
আমাদের এই লাউসি দেখলাম বইয়ের থেকে বুক থেকে তোমার হচ্ছে হোমওয়ার্ক দেয় না। আগে ওই লাউসিটা বুক থেকে দিত, বুক ফলো করতো।
হ্যাঁ, এনি বানায় দেয় মনে হয় না?
বুক থেকে দিলে ভালো হয় যতটুকু আমার ধারণা। এক্সামের জন্য বেশ উপকারী, কারণ গতবার এক্সামের সময় কিন্তু আমাদের ওই হোমওয়ার্ক গুলো বেশ কাজে দিছিল।
ওকে।
প্রতিটা ফাংশন থেকে একটা দুটো করে দিত, ভালো হতো। এই লাউসিটা আর কি আমি বলছিলাম ওই চ্যাটে যে বুক থেকে দেওয়ার জন্য, তা উনি নানান ধরনের কোশ্চেন করে।
Okay. So here is another thing. If f of x2 is equal to f of x1, okay, that means like we have here is A and here is B, right? So if you see that this point A, or we can say like x1, x2, okay? Here is x1 and here is x2. This 2 point is in between A and B. So this is f of x. This point is f of x. So you can see here for x1, not f of x, but f of x1 and x2. This point is 2 point, like f of x1 and also f of x2. So why? Because you see here, f of x1 is here and f of x2 is here, right? So their y value is same. Their y value is here. They are same. So if these two value is same, like if f of x1 is equal to f of x2, then our function is a constant function.
ওমর
Yeah.
হেডফোন ইউজ করতেছ নাকি?
না, হেডফোন ইউজ করতেছি না ভাই।
কেমন জানি বাড়ি মারতেছিল। আচ্ছা, এবার ঠিক আছে।
Okay. So you can see f of x2 is equal to f of x1. That means here is our x1 and here is x2, but their function value is same. Like you can see here, here is f of x1 and here is f of x2. So their y value is same at this point. So that's why this function is constant function. Constant function looks like y is equal to 5, okay? Y is equal to 2, like this way. And f of x on x2. And this function is not a constant function, okay? Because you can see the function value is different. For x on, f of x on is here. For x2, f of x2 is here. So that's why they are not constant function. D of x plus c for all x in AP. So I think we don't need this proof, like this proof, but we can just get some idea. F of x equals gx plus c, where if derivative x equal to g derivative x. So maybe this is like a formula, like if f derivative x is equal to g derivative x, then there will be a point between a and b. Then there exists a constant c, okay?
It's a formula.
Yeah, there exists a constant c such that f of x is equal to gx plus c. So this is like a formula, okay? So if f derivative x equal to g derivative x, they are two different functions. So there will be a constant c that is f of x is equal to gx plus c, okay? Maybe this is a formula and we don't need to prove this formula. It is little complex to understand. Though it is, I can explain, but let's skip this part for today. So we have a function y f of x is equal to x plus 1 by 2x. This satisfies the Lagrange theory on which interval? Lagrange theory. So x equal to 0, f of x is not defined. Yeah, because we can the denominator cannot be 0. And then so we divide, we just divide this 2x with x and 1. So it will make x by 2x plus 1 by 2x equal to 1 by 2 plus 1 by 2x. So again here x cannot be 0. So how this number can be 1, 2? Firstly, this function is continuous. No, this is not continuous. Y equal to 1 by x is not continuous at x equal to 0. And so we get 1 by 2. 1 by 2. So on which interval? 1 by 2, x equal to 1. 1 by 2 here. 1, 2, okay. So guys, you see here, this function looks like this way, okay? Because f of x is equal to x plus 1 by 2x. So if we just break down this this function, it will become 1 by 2 plus 1 by 2x. Prepared now. Let's say no, I'm prepared. Don't worry. Okay, so I have reviewed all those things, but just okay. So guys, see, Zakir, are you here? Farin is also here.
Yes, I'm here.
So
Yes,
can
I'm
you
here.
understand? Do you understand what I'm saying? What I'm saying? Hello.
Yes, yes.
Okay. So I'm trying to say that we have a function here, f of x is equal to x plus 1. So the question is, it satisfied the Lagrange theory on which interval? Okay, on which interval? So if we draw this function, it will look like this way. Because firstly, just break down this function. So you already know that if we have a denominator 2x, so we can divide x. We can divide like this way: x by 2x plus 1 by 2x, x by 2x plus 1 by 2x. Okay. Now x get cancelled and we get half and 1 by 2x. So here x cannot be 0, right? Because if x is 0, then it becomes 2 into 0. That means 1 by 0. So 1 by 0 is undefined, right? So that's why we do not keep in consideration. So that's why x cannot be 0. So you see here, if x is equal to 0, then this function has no value, or this function is undefined. So we have four options. We have four options: A, B, C, D. So in A, so let's see D. So in D we have 0, 1. That means it includes 0, but we cannot take 0, right? Because if x is equal to 0, then our function is undefined. So we cannot take 0. Then again here minus 2, 0. We again have 0. That means we cannot take this, also this one. We have minus 2, 2. So inside minus 2, 2, we have 0, right? Minus 2, 2 means minus 2, minus 1, 0, 1, and 2, right? So that's why inside minus 2, 2, we have 0. So we also cannot take this. But number A, we have 1, 2. So here is no 0. That means we can take this interval. So this is our answer, okay? Guys, can you understand? I am not
Or can
Laoshi,
you
I am
repeat
not
it?
Laoshi. I'm your friend. So you can just tell me.
Please repeat again. No.
Okay, so we have, so here is our function. And we can break down this function this way. So it is 1 by 2 plus 1 by 2x. Now we cannot take 0 here, right?
Yeah.
We cannot take 0 here. So if I draw this function, it will look like this way. And if x is equal to 0, then our function has no value. Because if x is equal to 0, then the whole function becomes undefined. Okay. Yeah.
I can understand this part.
Okay, you don't.
Wait a moment. I noticed. I can understand.
Okay, you don't need this one. Okay, you don't need this one. Just look at this. Look at the function. Okay. So we have x plus 1 by 2x. So firstly, you have to think in which value the function is undefined. So if x is equal to 0, then this portion becomes 0. And we know that if the denominator is 0, then this function is undefined. And also you can see in the graph, when x equal to 0, this function has no value. Okay. So now we know that we cannot take 0. So look at number D. We have 0 here. That means cancel. Look at number C. We have a 0 here. That means cancel. Look at number B. It is minus 2, 2. That means we have also 0 here. In between minus 2, 2, we have 0. That means also cancel.
Yeah.
So the answer is only A, 1, 2, because we don't have 0 here.
Okay, understand.
Okay, Zakira, do you understand? Farin?
Yes.
Yes.
Okay, thank you so much. So let's go to sketching monotonic function. What is monotonic function? Y equal to f of x, I, x1, x2. I is in x1, x2 is in I. Okay. So if x1 is less than x2, whenever x1 is less than x2, then function is said to be increasing. Okay, this is also very simple. For example, we have x here, x1 here, and x2 here. So we know that if this is our value, so then our f of x1 will be here, right? F of x1 will be here. And if this is x2, then f of x2 will be here, right? Guys, do you know this? You can also call it y1, comma
Yeah.
y2. Okay, no problem. Y1, comma y2.
Yeah.
Because we know that x is on the on x is on x-axis and y is on y-axis. Okay. So there is no problem with it. Now, if you look closely, then you can see x1 is less than x2, right? X1 is less than x2, and y1 is also, or f of x1 is also less than f of x2. So if this is the case, then our function is increasing. See here, our function is increasing. So this is the statement. If f of x is less than f of x2, whenever x1 is less than x2, then function is said to be increasing on I. Okay, guys?
Okay.
Yeah. So, and number two, we have the opposite thing. Like if if f of x, if f of x1, okay,
Less
if
than.
f
Less
of
than. Yeah.
x1 is greater than f of x2, whenever x1 is less than x2, then function is said to be decreasing. You see here, x1 is less than x2. X1 is less than x2, but f of x1 is greater than x2. You see here, f of x1, that means here, f of x1 is greater than f of x2, right? So this
Yeah.
function is decreasing. You see here? Okay. So guys, can you identify some increasing function and decreasing function inside of this graph? You see from minus infinity to 1. So from minus infinity to 0, sorry, to 0. This function is decreasing, right? And then from 0 to plus infinity, this function is increasing. Okay? So this function is y is equal to x square. This is y equal to x square function. And here we have y equal to x function. So between -1 and 1, -1 is less than 1. Then f of -1 is also f of, less than f of 1. That means function is increasing. The first formula, okay? This first monotonic functions formula. And we have y is equal to modulus x. So for modulus x, we know it can be x and it can be also minus x. So x when x is greater than 0, right? X is greater than 0. And minus x when x is less than 0.
Yes.
So from minus infinity to 0, this is increasing.
It decreases.
From 0 to plus infinity, this is, so from minus infinity to 0, this is decreasing. F of x is decreasing, and from 0 to plus infinity, f of x is increasing. And this function looks like this way. That means coming this way and going this way, okay?
Omar, I want to ask you something
Yeah, of course you can.
about the homework number 3.
Number 3, yes, number 3. Here is the,
Can you repeat that? Yes, can you repeat that again?
yes, of course I can repeat it.
Thank you so
It
much.
is, limit x tends to 0, root over on plus x minus on by x. So this
No,
is
no, not this one. 2.3, that one.
okay.
Before that.
Yeah. So here is our function, and the question is
Yeah.
we have to find the local and absolute extreme values of f of x. So we already know that we can find some extreme value at derivative of x is equal to 0, right? And derivative of
Yes.
the function is 0. So firstly, we calculate the derivative here. And then we write down like derivative is equal to 0. So you can see
But
here.
why did you cut the like first part? Like
Okay,
in the like in picture?
I just explained some normal theory here. That's why I maybe this part is not
Oh,
necessary. It is just
oh, okay,
for
okay.
me to understand.
Okay, okay, I got it. Okay, you can continue.
So the derivative of this function is 3x
Yes.
square minus 6x minus 9. And from our formula, we know that derivative of the function will be 0. Then we can find some critical value. So I just write this way. The derivative is equal to 0. Then I calculated here. You see here? So 3x square minus 6x minus 9 equal to 0. Then I just take this 3 out here. Then we get x square minus then 2x minus 3, okay? Or I just divide by 3. I just divide by 3 and multiply 3, okay? Oh, sorry, no. I just divide 3 here and also here. So it will make, so it will, this 3 and this 3 get cancelled, we get x square, and 3 and 6 we get minus 2, and 3 and 9 we get minus 3, okay? And 0 by 3 is 0. Nothing more complex here. Yes,
Okay,
can you
okay.
understand what I did here?
Yes, yes.
I just took 3 common and send this 3 down here. Or simply I just divided by 3 on the both side. Here and also
Okay.
here. Then 3 and 3 get cancelled. 3 and minus 6 makes minus 2. Okay. So then we have to break the middle then we have to calculate middle term break. That means we have to break this.
Middle term.
Yes, middle term. We have to break this this part. So how to break this part? We just multiply this first and the last thing. That means we multiply the highest coefficient. Highest coefficient is on here, okay, on. So on multiply highest coefficient with the constant. We multiply highest coefficient with the constant. So it will make minus 3. So we have to think how we can make minus 2 by adding 2 number. And we have to also make minus 3 by multiplying those 2 number. For example, minus 3. So we can write down this way, like minus 3 plus 1. So minus 3 plus 1, if we just add this 2 number, it will be minus 2. So we get our middle function, right? Or our middle part is minus 2. And then if we multiply these 2 number, like minus 3 and 1, so we get minus 3, right?
Yes, yes.
That means this part, or the coefficient and the constant value, the multiplication of coefficient and constant value. So minus 3. So we know that we can divide this 2x like -3 and 1. So I just write down like this way. I skipped on online here. It will be x square minus 3x plus 2x minus 3. So I just broke this part, minus 2x into minus 3x plus 2x. Sorry, plus only x, minus 3x plus x. Okay. Minus 3 gun multiply 1 is equal to minus 3. Okay. So this was our part. So we got x square minus 3x plus x minus 3. And then we take x common here. So you can see here on the upside. I did in detail. So see here, I just broke this part into this two part, and then I took x common from these two part, and then I took plus on common from this two part. So it makes x into x minus 3, and plus, if I common plus on, it makes x minus 3. Then again I just take x minus 3 common, and it will make x minus 3 into x plus 1. This x and this plus 1. This is x plus 1. So as these two function is multiply, as this function is multiplied is equal to 0. That means x minus 3 will be 0, and x plus 1 also will be 0. So now we get x equal to 3 and x equal to minus 1. So in number 3, I calculated it here, okay, very simply, or also here, the critical point values. So I got two critical point, one is 3 and one is minus 1. Okay. Now, what was our question? Our question was, what is the extreme value, right? Our question was,
Yes.
find that local and absolute extreme value. Okay, local and absolute extreme value. Local extreme value means local maximum and local minimum, and global extreme value means global extrema and global minima. So now you just substitute this x equal to 3 in the main function, like here, okay? And then again, you just substitute this minus 1 in main function here. You see here in point values. So if I substitute these two extreme values, if I substitute these two extreme value in main function, then I get minus 13, minus 13 and 19. That means this part, this is 3, minus 13, and this part is minus 1, 19. So this 2 point we put this in the graph. See here, this point and this point. Okay. This point here and this point here. So this 2 point is our global. This 2 point is our answer. They are our local extreme values and global extreme values. Okay, Farin?
Yes, Omar. Huh.
Okay, got it now. What is next? Find the critical point of f, identify the intervals on which f is increasing and decreasing. So this one is like the same. I just mentioned at the first place, like this function number 2. Okay, so find the critical point, identify interval whose function is increasing and decreasing, and find the local absolute and local and absolute extreme value. So this is critical point, increasing, decreasing. See, the same thing I just discovered. I just discussed previously. So critical point will be derivative of x equal to 0. Then find the value of x. This is 2 and minus 2. So we know that this 2 and minus 2, these two are our critical point. And for number 2, identify the interval on which the function is increasing and decreasing. That means if increasing, right? Three x square minus 12 is greater than 0. So there is a simple way, like we can just write this. We can just write this way, like our derivative is greater than 0. Okay, our derivative is, if our derivative is greater than 0, then function is increasing, and if derivative is less than 0, then function is decreasing. And then we just put the value here, like our derivative is 3x square minus 12. So we just put the value here. And then in our foundation math class, we learned how to solve how to solve an inequality, right? So just add 12 on the both side, and so this 12 and 12 get cancelled. So you get 3x squared is greater than 12, and divided by 3 on the both side. So you get x equal to, sorry, x square is equal to 4. Sorry, x square is greater than 4. And then you just make a square root on the both side. So you get x is greater than 2. Okay. So that means if x is greater than, so as x is greater than 2, that means you can see here, this is our 2, and greater than 2, that means 2 plus infinity. So this function is increasing. So how you understand? So to make it more clear, you just need to draw this table. I already discussed it before. Like our critical point is 2 and minus 2. So here is minus 2 and here is 2. That means here we have got 3 portion. One portion is minus infinity to minus 2, and another portion is minus 2 to minus 2 to 2, and another portion is 2 comma plus infinity. So 1, 2, 3, 4, 5. We have got 5 portion. So in interval we write this 5 thing, 1, 2, 3, 4, 5. Okay. And then if you find f derivative, that means you have to take any value inside of this function, like minus infinity to 2. So you can take like minus 3, minus 4, minus 5. Okay, any value in between minus infinity comma 2. So it is making 15. So 15 is a positive number, right? That means this function is increasing. And if you calculate minus 2, so just input this minus 2 where? Input this minus 2. Minus 2 here, okay? So this time we do not input this minus 2 in main function. Okay, so when we are just calculating the direction like upwards or downwards, so we put this value in this function, like in our derivative. And previously when we got our critical point, so we put this function here. here in our main function. Remember?
Yes, yes.
So, but this time we are taking this function here, or we are just substituting -2 here. So it will make 3 into -2 squared. That means 12 minus 12. So 12 minus 12 is 0, right? So this is 0. And f of 0. So here I have -2, 2. So I can take any value. Like I can also take 1. I can also take -1. But I cannot take 2 because this is a open interval. See here, this is open interval. So I cannot take -2. I cannot take 2. Okay. I must take something between -2, 2. So for example, I can take 0. So it will be -12. And if this is 2, then substitute this 2 here. So you will get 12 minus 12. You will get again 0. Okay. And we have 2 comma plus infinity. So for example, we just take 3 here. So we get 15. So 15 is also positive number. So if it is a positive number, then function is increasing, and if this is a negative number, then the function is decreasing. Okay. Choose a special point of the interval and calculate the derivative value of this point. Derivative value. So this is called derivative value. Okay. F of 3, this is called derivative value. F of 0, this is called derivative value. Thus, the increasing intervals are -infinity to -2 and 2 comma infinity. So you can see here increasing -infinity to 2, and also here increasing -2 comma plus infinity, and decreasing is here -2 comma 2. Okay, because this is minus. Okay, so here is some more example like before, so we don't need to discuss. And here is L'Hopital's rule. I already told you what is L'Hopital's rule. You just need to differentiate the upper function and also the down function, or you just differentiate the numerator and denominator. So you see here, sin x, differentiate of sin x equal cos x, and differentiate of x equal 1. So just it will make cos x by 1, or and then if x equal to 0, limit. So you don't need to remember these complex things. Okay, I already discussed it before. Like here is 3x minus sin x. My device battery is finished. Okay, Topu is leaving. So limit x tends to 0, 3x minus sin x by x.